Today in Capechi's Corner, we are going to look at solving equations. Now, this is a topic you've done definitely in Algebra 1 and pre-algebra, so we're just going to do a quick refresher. When we are translating verbal to algebraic expressions, these phrases are going to be very helpful when you're doing word problems. So when we're concentrating on the word addition, any words like sum or more than or plus, increase, or added to, the operation you're going to use is addition. When you're looking at subtraction, that's going to be something like subtracted from, less than. Difference is a common one that you see a lot. Decreased by, or minor, all minus. All of those words are going to be used when we want to do the operation of subtraction. Now, when we're looking at multiplication, again, the word product, which most students are comfortable with, you've seen that before. Multiplied times. The biggest word that a lot of students aren't familiar with is the word of. If I say I have 1/3 of the number of people in the classroom, of means times. So that's something using your multiplication there. And the last part there is division. Words like quotient and divided by, they go along with the phrase division. Now we're going to solve some basic equations. So whenever you're solving an equation, again, the word solve, which we've talked about before, means I want to get a variable by itself. X is equal to a number, or M is equal to a number, whatever it is. And you're going to use the inverse or the opposite operation to isolate the variable to solve the equation. So here are some basic equations for you. So in number 1, I have x plus 3 is equal to 7. There's my wall. I like to draw my wall and my equal sign. I'm trying to get x by itself. So I have plus 3. My opposite operation there is minus 3. So I have x is equal to 4. That's my final answer. Now, when I'm looking at my next problem, I have m minus 2. So again, there's my wall. Opposite operation, I'm going to add 2 to both sides. And I have m is equal to 12, which is my final answer. So now we're moving on. I have the next problem says 3x is equal to 12. I'm multiplying, so I'm going to divide both sides by 3. And I have x is equal to 4. And my last one here, I have y over 7 is equal to 3. So y over 7 as a fraction is division. So again, my opposite operation is multiplication. I'm going to multiply both sides by 7. So y is equal to 21. So again, that's just some basics on solving equations. Now, as we move on, we'll do some that are a little bit more advanced. Again, but review from Algebra 1. So in number 5, I have 18 is equal to 3/4 t. Now, this 3/4 is 3/4 times t. So I can either divide both sides by 3/4, which is fine, but I don't always want to use a calculator. So if I just multiply by the reciprocal, that's going to get me the same thing. Because what happened on my right-hand side of my equal sign, my 3's will simplify, my 4's will simplify, and I'm left with t by itself, which is what I want. So 4 times 18 divided by 3. Well, I can say 3 goes into 18 6 times. So I could simplify there if I don't want to use my calculator. And I have 24 is equal to t. Now, the difference between that and number 6 is if I'm going to want to isolate my variable, first I have to get this 1 on the other side. So I have 19 is equal to 3/4 t. Now, this might be a time, again, I can either multiply both sides by 4/3 or use my calculator. Doesn't matter which way I do it. So if I multiply both sides by 4/3, use my calculator a little bit, and I get t is equal to 25 1/3. Number 7, I have parentheses, so I want to distribute. So I have 5x plus 15 plus 2 minus 2x is equal to 14. So that gives me 3x plus 17 is equal to 14. If I subtract 17 from both sides, I have 3x is equal to -3. So x is equal to -1. Same idea for number 8. So I have 53 is equal to 3y minus 6 minus 6y plus 2. Again, on my right-hand side, before I start moving things, I'm going to combine my like terms. So I have -3y minus 4, add 4 to both sides, and I have 57 is equal to -3y, so y is equal to -19. Now again, if you wanted to double check your work, you could substitute y back in in the beginning for negative 19. Wherever you see y, that's the value you have. If you get a true statement on the left and the right-hand side, you know you did the problem correctly. The area of a trapezoid, which is a is equal to 1/2 times the height times the base 1 plus base 2. So in this case, we're asking to solve for b2, so b sub 2. So the first thing I'm going to do, I don't like that fraction there. Now, I'm looking to solve for b2, so I'm trying to pull things apart to get that together. So I'm not going to distribute. First thing I'm going to do is I want to get rid of that fraction. If I multiply both sides by 2, this gives me 2a. This 1/2 times 2, that simplifies to 1. So then I'm left with h for height times the sum of the bases. Now again, I want to get base 2 by itself. So I'm going to divide, do the opposite operation. And I have 2a all over h is equal to b1 plus b sub 2, because that will simplify. Now the last thing I want to do is I want to subtract b1 from both sides, b sub 1. So I'm going to rewrite this, subtract b sub 1. So I'm left with 2a, the fraction 2a over h, minus b sub 1 is equal to b sub 2. Now in our last problem for today, with the same type of idea, I want to get L by itself. I'm looking at the area of a surface area. So my L is part of that term right there. So the first thing I want to do is I don't need this second term right here, that's pi times r squared times the radius squared. So I'll subtract that from both sides. And I have s minus pi r squared is equal to pi times r times L. So again, I want to get L by itself. So I'm going to divide both sides by pi r, both sides. Now I can't simplify these pi's because I don't have a pi on the other side. This pi times r is underneath both my term of s for surface area and pi r squared. So I just have to leave that. So this will all simplify. So my final answer there is s minus pi r squared over pi r, and that is equal to L.